Good morning, class. Today we are going to discuss quiz chapter 4 Introduction to Organic Chemistry, chapter 5 Hydrocarbon, and chapter 6 Benzene ring. So the first question, which of the following skeletal structure represent the compound below? Okay, so if you check the option right, O is expanded structure. So here COH is the same. So should be no problem. COH should be no problem. Here also the same. There is a COH. Okay, and then we have to check for the there is two methyl group, so methyl group. Okay, for this one there is no methyl group, so out, no methyl group out. How about this one? Yes, there is a methyl group. Okay, so now the option is between A and C, A and donkey. Yeah? Okay, if you check carbon number 1, 2, 3, carbon number 3 there is chlorine. Yes, carbon number 3, say here's 1, here's 2, here's 3, there is a chlorine. Yes. But why? Here there is a methyl group, meaning that answer A is wrong. Check another one. Okay, yes, carbon number 1, carbon number 2, number 3, there is a chlorine. Yes. And then 4, 5. Okay, 4, here is the 4, and then 5. So that's why the answer is donkey for question number 1. Okay, now we go for question number 2. Choose the most stable carbocation ion. So over here, this one is secondary because attached to 2 carbon. And then this one attached to 1 carbon is primary. This one actually attached to 1 carbon as well, primary. And then this one, 1, 2, 3, tertiary. That's why the answer is donkey because it is a tertiary. Carbocation ion is the most stable carbocation ion. Okay, now we go for question number 3. Which of the following compound exhibit geometrical isomer? First of all, must have double bond or cyclic. Okay, this one got double bond and cyclic at the same time. That's why cannot form the geometrical isomer. For this one, yes. For this one, cyclic compound might be, but for G confirm no, because there is no cyclic, no double carbon-carbon double bond for donkey. Okay, but you have to take note, okay, for this cyclic compound, they have the same group over here. That's why cannot. If you check for the rules and regulation, either it's carbon-carbon double bond or cyclic compound with 2 different groups. So here is 1 hydrogen, here 1 hydrogen. Then with methyl group, this one is ethyl group. So yes, the answer is boy. Okay, now we proceed for question number 4. Identify the type of reaction. So this one we know is negative charge, which is nucleophile. So you have to alert this is nucleophile. So, and then you check, okay, the OH actually is replaced by Cl. So it's nucleophilic substitution reaction. Okay, question number 5. The number of possible structure isomer for chlorobutane C4. Okay, if I try to draw C4 with straight change, okay, this is C, C, C. Okay, the position of the chlorine can be C1 or C2. So there are 2 possibilities for C4H9 with straight change butane. If another one we try to change to propane with 1 branches, 1, 2, 3, okay, with 1 branches. So the position of the chlorine, right, can be here as the tertiary haloalkene or can be here. Okay, always take note that the position here, here, or here actually is the same. So that's why there are 4 possibilities, 4 structural isomer for chlorobutane. So the answer is A. Okay, 2 types of stereoisomer. We must know stereoisomer is the 3-dimensional way. So the first one is diastereomer, cis-trans isomer, or enantiomer, optical isomer. So the answer is B. Okay, position, functional, change, actually all under structural isomer. Alert. Okay, next question number 7. The hydrocarbon C5H12 contain a quaternary. Okay, so I try to draw it. Quaternary means attached to 4 carbon. Okay, so this is the simple structure for C5H10 quaternary. Okay, quaternary means refer to this carbon. Okay, refer to this carbon. So what is the IUPAC name for this hydrocarbon? Okay, so the parents is propane. There are 2 2-dimethyl group. That's why answer is C. Okay, I hope everyone of you still follow with me. Now we proceed with question number 8. Okay, hydrocarbon. So C6H14. So highest boiling point. If highest boiling point, sure, I will choose the straight change compound. C, 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 C. 1, 2, 3, 4, 5, 6. So this is the highest one because straight change compound has larger surface area of contact, so stronger the van der Waals forces. So the answer is C. If you check here, there's branch, 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 branch. Even though having the same carbon, same number of carbon, 6 carbon, but if you branch, right, okay, the highest number of branches, right, the more compact. That's why smaller surface area. So lowest boiling point. Okay, so since question asks about highest, so we just focus the straight change one. Okay, we can condense is the CH2 like this 4 carbon with CH2 4. Okay. Okay, and then next question number 9. What are the product form of combustion? Okay, excess oxygen. Confirm the answer is CO2 and H2O. Carbon and hydrogen gas. Okay, hydrogen gas cannot. Monoxide gas and water. Okay, this one happen when in limited oxygen. Then carbon dioxide. Okay, this is impossible. If the question asks about limited oxygen, so the answer is C. Very limited oxygen is carbon and water. Okay, question number 10. Arrange, okay, these three hydrocarbon compound in order of increasing boiling point. First of all, I will check for the number of carbon. Propane 2,2-dimethyl 5C. Okay, and then this one pentane 5C. Okay, and then this one 2-methylbutane. Okay, 5C as well. So meaning that all of them having the same molecular formula, but the structure is different. So increasing boiling point meaning that from lowest until highest. So I know pentane is the highest because strict change. Okay, so these two option out. And then this one with two branches, this one with one branches. So one branches higher boiling point. So this is position number 2. So 2-methyl is position number 2. So the answer is A. Okay. Okay, question number 11. Choose a propagation step for the reaction of bromine with propane. Okay, so propagation step means step 2. Okay, if you look at this one, actually is step 1. Change initiation step. Okay, this one actually is change termination step, step 3. Okay, yes, this one is step 2, change propagation step. Involve bond forming and bond breaking. Okay, the last one, there is no free radical. Okay, both side no free radical, that's why this is not related with the free radical substitution. So the answer is C. C is change propagation step. Okay, madam, just do a quick review with you all. Always remember free radical substitution involve 3 steps. Step 1 is this one, change initiation step with UV. It will form 2 free radicals. The function of UV is to provide energy for homolytic cleavage to happen to form 2 free radicals. And then step 2 is this one, C, change propagation step. There are two possibilities. Okay, can be the bromine react with the free radical alkyl group or the free radical react with the alkane. And then step 3 is change termination step. There are 3 equations. Okay, always remember there are 3 equations. So either bromine, halogen versus halogen, halogen versus alkane, alkyl free radical, or alkyl free radical versus alkyl free radical. So this is very important for your practical test. Please remember how to write the mechanism for free radical substitution correctly. Please take note. And then, okay, question number 12. Which of the following product will obtain when liquid bromine, meaning that this one is bromine in inert solvent, is added to cyclohexene? Okay, actually this is electrophilic addition. 2 bromine atom will be added. So the answer is B. No doubt. Question 13. Which of the following reaction 1,3-dimethyl cyclohexene is correct? So first of all, you must know how to draw the 1,3. Okay, so this is C1, this is C2. So at the C1 there is a methyl group, and at the C3 there is a methyl group. Okay, so okay, madam will, okay, for sure this is related with electrophilic addition. For electrophilic addition, we have to always remember Markovnikov group. Okay, so this is the C1. 1, 2, 3, 4 with 4 bonding already, so full. So there is no hydrogen. Okay, this is C2. 1, 2, 3. So meaning there is 1 hydrogen. So if follow mechanical rule, right, okay, the electrophile will add it to the C2. The electrophile will add it to the C2. Okay, take note, huh? So in this case, HBr. So in this case is HBr as well. Okay, and next, what is the next? Okay, this one is BROH. Okay, BROH. Okay, then this one is oxidation. Okay, we check for the ABC first because T is not related. Is another story. Okay, over here this one is electrophile. This one is electrophile, and then this one is the electrophile. So by right, hydrogen should be added to here. Oh no, sorry. Hydrogen should be added to here. So hydrogen should be added to here. So the answer for A is wrong. Okay, this one have to alert peroxide. By right, hydrogen should be added to here, but anti-marker nickel group, so Br added to here, correct? Okay, this one Br should be added to here. Another one should be here is hydroxide. So this one is wrong, so be hydroxide. So C is wrong. Okay, so for the time being, answer B is correct, but we check for D as well. So KMnO4 breaking over here. So breaking over here will form double bond O. Okay, and then here will form double bond O as well. Okay, but take note, there is one hydrogen over here. So the hydrogen will continue oxidize become OH. So carboxylic acid is formed. That's why D is wrong as well. So the answer for question number 13 is B. Okay, you have to be familiar with the chemical reaction of alkene when answering this question. Now we proceed for question 14, major product. Dehydrohalogenation of 2-methyl-2-chloropentane. First of all, I have to draw pentane first. 1, 2, 3, 4, 5. There are 5 carbon. At the position number 2, there is a methyl and chloro. Okay, so over here, right, if I straight away, I want to form alkene, right? So I need to form the carbocation first. So I will form the carbocation like this. Okay, here is the carbocation. And then C. Okay, now which one? Okay, since this is tertiary carbocation already, it's very stable. So I can form the double bond over here or form the double bond over here. So I have to choose C1, C2 or C2, C3. The answer confirmed is C2, C3 because this one more highly substituted. There are three substituted tri-substituted group. If I choose C1, C2, only 2 substituted group. So this is the answer. So the answer is 1, 2, 3, 4, 5 pentane at the position number 2, 2 methyl, and then the carbon also position number 2. That's why the answer is C, 2 methyl, 2 pentane. Okay, question 15 actually is chemical test. So which one is the chemical test for butane? For sure, the answer is bromine in inert solvent, decolorized of reddish brown color. Okay, for your information, ABD actually is chemical test as well, but you haven't learned. This one is special for alcohol. Okay, we call it as Lucas test to identify the class of alcohol. And then this one we call it as iodoform test to identify the methyl carbonyl or methyl carbonyl group. Okay, this one is special for carbonyl compound C double bond O. We call it as Brady test. 2,4-dinitrophenylhydrazine. Okay, you are going to learn soon. Okay, ozonolysis of compound produce propanol and methanol. So now identify X. As we know, right, ozonolysis, the purpose of ozonolysis is to the carbon double bond cleavage. At the same time, right, the question might ask you, join back. You have to join back. Okay, so the first one propanol. Okay, like this, there are 3 carbon. And then another one is methanol, 1 carbon, means CH2O. CH2O. So the total carbon in this case is 4. So butane, yes. Butane methyl, so total 5 carbon. That's why option 1 out. Butane methyl, option 2 out. Cyclopropane, impossible because cyclo, right, after you break it, only you form one product, so impossible. Without identify what is the product, right, we can eliminate the option. So based on here remain B. So we try, meaning that C is over here. Okay, meaning that bond breaking is formed initially should be like this, and then form bond breaking, and then form the methanol and the propanol. So this is the original structure for the alkene. So what is the name for this one? Propane, and then substituent at the position number 2. So it's this is 1, this is 2, this is 3. So C1, C2, C3 propane. Okay, position number 2, this is the substituent, so it's 2-methyl propane. Okay, question number 17 is related with benzene. Not true. Okay, first, the carbon atom benzene form regular hexagon. Yes. Each carbon with 3 sigma bond. Yes. Why we say like this? Okay, we try to draw the benzene ring. Okay, alternate alternate double single bond. We check there's one hydrogen over here. Okay, so use another color to represent it. So you see, okay, 1 sigma, 2 sigma, 3 sigma, and then here there is 1 pi bond. So that's why for a benzene ring, when you check the bonding, actually is 3 sigma plus 1 pi. So since the question mentioned about 3 sigma, yes, correct. Okay, each benzene ring has 3 delocalized electrons. So the answer is wrong. By right is 6. Why? Over here there are 3 pi bonds. Each pi bond equal to 2 electrons. That's why the answer is 6 electrons. And then each carbon atom use sp2. Yes, because just now we mentioned already 3 sigma, right? 3 sigma sp2 hybrid orbital. So it's trigonal planar. If you check for the hybridization diagram for C6H6 benzene ring, right? Actually is combined of 6 trigonal planar carbon. Okay, question number 18. Are you back name for the following compound? So this is benzene. Okay, position. I know this is bromo, this is fluoro, this is nitro. If possible, right, we have to assign the lowest one. Okay, we try to do this. Okay, this 1, 2, 3, 4. Here 1, 2, 3, 4. Okay, so this is the lowest. 1, 2, 3, 4. But 4 bromo have to come first because according to the alphabetical. And then followed by F, and then next is N. Okay, since position of fluoro-nitro is the same, straight away 2,4-nitrobenzene. So the answer is B. Okay, what is the role of uric acid in halogenation of benzene? For sure is act as catalyst. Okay, without catalyst, right, the 4 electrophilic aromatic substitution of halogenation, alkylation, oscillation, or bromination of benzene won't be happen. The uric acid is very important for the reaction of electrophilic aromatic substitution of benzene ring. Please take note. Okay, and then the last question, question 20. What is the major organic product form from the following reaction? C with UV. For sure, this is free radical substitution. Always remember, free radical substitution only happen at the outside the benzene ring. So meaning that it's over here. Over here, okay, we check. Okay, the first possibility is over here, but for sure this is not the answer because this is primary. Okay, impossible. 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 Why? Because all have to happen outside the ring. So this is happen inside the ring. That's why answer for A, B, C is impossible. So the remaining answer is like this one. The bromine attached to the outside carbon. The methyl benzylic. Okay, benzylic. Wait as benzylic. What benzylic? Actually this is benzyl chloride. Benzyl chloride will be formed. So this is the answer. Okay. Oh, sorry, it's benzyl bromide because it's bromine. That's all for the quiz discussion. Okay, hope you all can score for UPS too. Good luck. Bye.